In today's lecture, we are going to be talking about some basic inventory principles. If you recall, in the last two lectures on aggregate production planning, we had seen that the major problem was concerned with fluctuations of demand, and maintaining inventories to meet that fluctuating demand was one of the important means of dealing with such fluctuations. In this particular lecture, we will devote ourselves primarily to how inventories are handled, whether they are really relevant, what functions they perform, and what would be a computerized inventory management system. So these are the basic issues that we will be talking about in this particular lecture. Basically, inventories are idle resources maintained in various forms. So the question that obviously arises is, if they are idle resources, why do we keep idle resources? Because in any situation, you would not like to see your manpower idle, you would not like to see your machines idle, you would therefore not like to see your machines idle, materials idle. So what is the basic purpose of keeping inventories? And we must also recognize that inventories are maintained at various levels throughout the manufacturing system. For instance, we talk about inventories of raw materials. Whatever materials are received in the factory, you often maintain stocks of these raw materials, and quite often, depending upon the nature of the factory, you might find huge chunks of raw material lying there as inventory. So it is not only occupying space, but it is also at the same time blocking up capital which could have been put to productive use. So in that sense, it's there. Then inventory may be in the form of purchased and manufactured parts which have to be purchased from outside and parts which have to be manufactured within the plant. Both of them constitute inventories, and you find inventories at that level. Then as you proceed among the manufacturing process, you find that there are sub-assemblies, and these sub-assemblies are also nothing but work in progress inventory. And finally, when you talk about the finished products, those also are inventories. So what it really shows is that the presence of inventories is there at every stage of the manufacturing, starting from raw materials to purchased parts to sub-assemblies to finished products. And we also recognize the fact that since inventories represent a sizable investment in a logistics system, we must be aware of the functions they perform. That means we must be clear in our mind as to what kind of functions inventories would perform. Why are we maintaining inventories, keeping idle resources with us at that particular point of time? I think it would be interesting to see that there are different categories of stock. For instance, the first category of stock, and one of the major purposes of inventories, is what we call pipeline stocks. That is in process stock or in transit stock. And therefore, what we mean by this is that you take the analogy of a pipeline which is used to supply water, for instance. You will never get water at the tap unless the pipeline is full. So if there is no water in the pipeline, you will never get water at the point where you need it. Something similar is required in the inventory design system, because unless the assembly line is full, you will never get a car at the end of the assembly line. So these kinds of inventories which are there are actually called pipeline inventories or pipeline stocks, and there is really very little you can do about them. The only way to minimize pipeline stocks would be to design a better method of distribution. That means design a piping system which has lesser length, lesser diameter maybe, and then you are able to use this for purposes of maintaining the amount of water stored in the pipe is minimized. So it is equivalent to saying that the inventory stored will be smaller if the length of the assembly line is smaller. However, if you have very large lengths of the assembly line, you will have much greater stocks which are in process, and therefore this is a major thing. Therefore, basically pipeline stocks which make the inventory function properly can be reduced only by design, better design of the system. You cannot improve them by improving the operational performance of that particular system. Okay. So this is the first function of inventories, that they are actually pipeline stocks and therefore they are necessary in that sense. The second category of stocks which we often talk about are called cycle stocks. Cycle stocks occur, for instance, in batch production owing to economies of scale or to technological requirements. What this means is that when you are producing, instead of producing one item at a time, you often tend to produce in batches. So if you are producing a certain quantity, you might produce, let's say, in batches of 100. So when you have batches of 100, you are not consuming at the same rate. The production rate is typically higher than the consumption rate, so you have stocks accumulating. And this accumulation of stocks is what we call cycle stocks. And basically, when you are talking about economic order quantity and its determination, you are trying to actually minimize the costs associated with cycle stocks. That's the whole purpose. The third categories of stocks that we talk about, inventories, are what we call seasonal stocks. So these are like time varying requirements of an item. Whenever an item is produced, you require probably these stocks in much greater demand, or whenever raw materials are available, you stock them. For instance, products, agricultural products which are produced in various seasons, what do you find? For instance, if you visit a sugar factory, you invariably find that sugar cane is stored in large quantities just outside the sugar factory in certain seasons when the sugar cane crop matures, and after that it's not available. So that's an example of a seasonal stock. And there are time varying requirements of an item, so because of these you can have seasonal stocks. Another reason for maintaining inventories is in the form of safety stocks. So safety stock is there generally because of the supply and demand uncertainties, and also because of uncertainties in the lead time. If you are 100% sure that your demand during the month is 100, you will order 100 and be satisfied with it. But if it happens that in some periods it is 80, in other periods it's 120, so there are these kinds of uncertainties. So you have to maintain some kind of safety stock of these items so that you don't run out of stock in that particular period. And similarly, if there are uncertainties in the lead time, that means if it takes time for the vendor to supply your requirements and this time is variable, if it were fixed there would be no problem. You can order at a certain time and get the supplies. But when the lead times are uncertain, then the time at which you place the order will also be uncertain. So you have to maintain safety stocks to deal with such uncertainties. There could be stocks held for other reasons. For instance, one of the major purposes of holding stocks for other reasons is the decoupling function as far as the inventory stages or the production stages are concerned. For instance, if there are in a factory a number of machines connected from one to the other, and the production process is going on from one stage to the next stage, then in order to decouple the individual stages, what would be required is that you can hold stocks between the machines which are actually trying to decouple the various machines, so that even if one breaks down, the other one can keep on working. That is the decoupling function of inventories. And it could also mean that you have situations like quantity discounts, price discounts. Also there might, another reason for holding inventories might be speculation. You expect, for instance, that the price of a certain good or a commodity is likely to rise, and therefore you hold stocks of that inventory in the hope that whenever these prices rise, you will sell the commodity, right. So in fact, trading in shares is basically an example of this kind of a situation. So these are the basic purposes or functions of maintaining inventories in this particular situation. Now let us see that what are the costs that are incurred as a consequence of retaining inventories. By and large, we can say that inventory related costs can be of three different kinds. The first kind of inventory related cost is what we call a procurement cost, and generally when you are talking about procurement cost, we can talk about various types of costs here. We can talk about the cost of goods, but generally the cost of placing the order is fixed and generally not dependent upon the order quantity, right. That means the cost per order therefore is generally a fixed quantity, and it does not depend upon how much you order, whether you order 20 items or whether you order 100 items from a person who comes to you. Let us say, suppose you are a shopkeeper and you maintain a shop where you have stocked different kinds of items. Then the supplier who comes to replenish your stocks, the cost per order would be the same no matter what is the order quantity for him, right. So that is why generally order quantity is the order cost per order is not dependent upon the order quantity as far as the procurement cost is concerned. Then there are these two very important types of costs. One, costs associated with existence of inventories, and number two, costs associated with non-existence of inventories, right. So we have costs of holding inventories and costs of stock outs, essentially, if you don't hold out inventories. So normally costs associated with existence of inventories generally occur when the supply tends to exceed the demand. So when the supply exceeds the demand, then typically we have items in stock, and the cost per unit time is generally written as I into C, where I is the inventory carrying cost rate and C is the unit cost of the item. So what we are trying to say is that quite often it is common to express the cost of holding inventories in terms of a percentage of the cost or unit cost of the item, in that sense, and small I here refers to what we call the inventory carrying cost rate. The other type of cost that we are talking about is the cost associated with stock outs. That means a stock out is a situation where there is a demand for something but you have no supplies available, right. So it is the opposite of this situation. That means the demand now exceeds the supply, you do not have the supply available. So the typical way of handling these costs could be in the nature of either cost per unit or in terms of cost per unit time. This would typically depend upon whether you are dealing with a lost sales or whether you are dealing with a back ordering situation. because when you deal with a back ordering situation, the cost associated is a function of the cost per unit time, that is after how much time can you satisfy the customer. So it's generally back ordering cost would have these units. But when it comes to a lost sales, if a customer walks into a store and he doesn't find a particular shampoo of his choice, he just walks away from it. So that sales is lost as far as the stores is concerned, and the lost sales can be therefore expressed in terms of cost per unit in that sense, because it is not back ordered. So these are generally the major types of costs which are involved when you are dealing with inventory decisions. However, in order to estimate these costs in real life, what you need is a thorough understanding of which type of cost will go into what particular component in the inventory. So let's look at that. For instance, when you look at the costs of procurement, the procurement cost generally is composed of these two components. One is the cost of goods, the second is the ordering cost. Cost of goods is the price of the item that you pay, and therefore this is the cost that you incur anyway. And the ordering cost is in fact the cost that you incur in placing the order. And here of course we had said that cost per order is generally fixed and is not dependent upon the order quantity. I hope you are convinced of this, because let's again take a small example and say for instance that there is a shopkeeper who has to replenish his stocks every week. So what he probably does is that he engages every week a three-wheeler or a taxi, depending upon his financial position. Suppose he engages a three-wheeler and then he goes to the main market, he goes to Chowdi Bazaar, he buys all the items and he keeps them in the three-wheeler and brings them back. So the cost of the order is the cost of operating the three-wheeler from home to the main market and then coming back. So that cost is constant irrespective of whether he buys whatever he buys there, provided of course the total amount that he buys can be accommodated within the three-wheeler. That is what we are trying to say. So that is the reason why we say that cost per order is generally constant. However, this cost per order that we are talking about, it generally contains these components in a industry. It talks about an administrative component. So the administrative component is the cost of preparing the purchase order, doing all the paperwork and so on. So that cost, placing, making all the inquiries which are required and things of that kind on telephones and other things, faxing, other things. So that is the administrative component. Then there would be a handling component. When you buy the goods, you have to handle them from that place to your premises. So there are always costs of handling. You might have professional packers to do this job for you, or you might do it yourself. So the nature of the handling, nature of the product determines how much handling costs you have. Then there is a cost of transportation, and then there is typically the cost of inspection of arrivals. Once the items are received within your premises, you inspect them to find out what is the nature of the arrivals. Are they okay, good, bad, how many breakages have taken place and so on. These types of costs are involved here. So all these costs go into the ordering cost component of the procurement cost, and the cost of goods is basically what you pay to the vendor as the cost of the goods. So after the procurement costs, we talk about the inventory holding cost. This is generally, in fact, this is the major inventory cost that we are talking about here. and the inventory holding costs, as we had said, are costs associated with the existence of inventories. This would happen if supply exceeds demand, so that you have a stock of goods, and typically the unit is cost per unit time, which is expressed as the inventory carrying cost rate multiplied with the cost of the item. And the typical components which are included here, if you were to estimate these costs in any realistic situation, would be the cost of storage and handling, would be the interest on tied up capital. This is generally one of the most important components of the inventory holding cost. Quite often people tend to say that interest on tied up capital is in fact the major holding cost. Property taxes, insurance, spoilage of items. You see, if you stock items in a store, then on the average, if you stock 100 items, whatever they are, some would get spoiled as you go. So that spoilage cost is also a part of holding. Obsolescence cost is also a part of inventory holding cost. If there is a store which stocks a certain kind of item or a certain type of let us say shop taking cell phones, for instance, and there is a lot of the obsolescence rates in such items is pretty high. So all the older models would in fact become obsolete very soon, and these obsolescence costs could be carried over to inventory holding costs. Pilferage is another important thing. I mean, most stores would have data available on, let's say, if they have stocked 1000 items, at the end of day maybe 20 are pilfered, something like that, right? So that additional cost is in fact a cost of pilferage when items are being stored, typically.
Sir, how are storage and handling costs different from property tax?
How are storage and handling costs
Different from property tax?
Storage and handling costs are the amount of cost you require to, let us say, hire a storage space and to employ people and equipment to transfer the goods from that place, put it in the various stacks. So that is storage and handling cost. It's entirely your cost, right? Property taxes are the taxes you pay on the building that is there, right? So it's like saying that property taxes are like, I stay in a house, I pay a property tax, and storage and handling is whatever I store inside the house is not a part of property taxes. It's I have decoration pieces, I have other things on the wall and so on. So that is the storage and handling of those pieces. So same thing here. Okay. So these are the typical components in the inventory holding costs, and basically you have to consider all these components. Now what really happens is that you might say, for instance, that of the total inventory holding cost you might estimate this one independently, and then find out what is the inventory holding cost. And therefore what is normally done is that this inventory holding cost is generally estimated by estimating the value of I, the inventory carrying cost rate. Suppose an item costs 1000 rupees. You want to find out what is the cost of holding it. First you say, okay, the interest on tied up capital is the main thing, which means that if I hold an item worth say the interest rate is 10%, say, right? So what does it mean? An item of 100 rupees I would be paying an interest of 10 rupees on that particular item. So on 1000 rupees I pay, let's say, 100 rupees in that sense, okay. Plus there are these things, so maybe 5 rupees for this and 10 rupees for this. So what you can possibly say is, at the end of the whole show, that instead of taking this as 10%, you might take it as 12% or 15% as the cost of handling inventory to account for the various factors, right. So this is the manner in which the inventory holding costs are typically determined. We may then talk about shortage costs. these are costs associated with stockouts. That is, we are talking about a situation where the demand exceeds the supply, and therefore if it's a loss sale, it would be in the nature of cost per unit, and if it is a back order, then it would be in the nature of cost per unit time. And typically these costs would consist of components like additional costs of a special order, right? Because if something is not available on stock, and if you have a customer and a special customer for whom you have to make it, then the additional cost of making the special order is a shortage cost. Back order if possible, of course, then it's okay, but there is loss of customer goodwill and there are lost sales both. So these are the kinds of components associated with shortage costs typically. Shortage costs, incidentally, are generally more difficult to estimate than the inventory holding costs. The reason for this is
intangibles.
They are intangibles, right? Very true. For instance, loss of customer goodwill is intangible. Some company says if I lose a customer, it's equivalent to, let's say, 50 rupees to me. Some other company says no, it's equivalent to 100 rupees for me. Now, how do you assess what is the loss of a customer to you? It depends upon the company's policy towards its customers in that sense. Okay. So depending upon the kind of policy that it has, it would then assign appropriate shortage costs for that particular situation. I think a very important principle in dealing with inventories is what is known as selective inventory control. And many of you may have heard of this term, that if you have a large number of items or if you have a large number of people, there are always a significant few and insignificant many among them. In fact, this law is known as Pareto's law. Okay. Now, Pareto's law applies very well to inventory situations, and what typically happens is that if you look at organizations, they deal with a very large number of stocked items. Typically the number of items could be 10,000 to 100,000 or even more, right? For instance, if you're talking about a company like Maruti Udyog, the number of components might easily go into something like 30,000-40,000 or even more, right, that they stock. If you talk about a company like Boeing, which stocks spares for aircraft, the number of aircraft spares might even run into millions, right? So it could be a very large number. So the number 10,000 to 100,000 is not uncommon. So what we are trying to say is that you have a large variety of these stocked items. In this particular classification into selective inventory control, we talk of classification on three different terms. We can talk about classifications and rankings of the inventory on the basis of value, on the basis of criticality, and on the basis of the usage frequency. When we talk about classification of inventory on the basis of value, we actually say that for each item we calculate the annual demand, we multiply it with the unit price, and then we sort of put these items in the descending order of their value. Value is the annual demand and the unit price, and take the cumulative value in that sense. So what would always happen is that this results in what is called ABC analysis. A class items are the ones which are most important, B class are the ones which are less important, and C class of the items are the ones which are least important, and this importance is determined to a very large extent on the annual value of the item. For instance, you find that a few A class items would generally be responsible for something like 60 to 70% of the total sales revenue of the company. and then B class would be slightly lower, and C class would be a bulk of the items would be responsible for only small contributions to the inventory, to the value. So this particular thing is known as ABC analysis. Many firms tend to use the term always better control for ABC, because this helps them in the sense that out of 10,000 items, you can identify 10 or maybe 50 items which are A class items and which need to be monitored very closely, and the other items, B and C class items, need not be monitored that closely, and you could set up a general policy for them. And so this makes inventory control for so many items much easier. That's the importance of ABC analysis based on value. The other thing is criticality. What do we understand by criticality of an item? You see, an item might be worth 10 rupees, but it might be very vital in the engine assembly of a particular brand of cars, let's say. So not a very expensive item, but a vital item, because if it doesn't function properly, then it could lead to a catastrophe as far as the product is concerned. Such items are called vital items. Then we have essential items, and then we have the desirable items. So VED analysis is another way of looking at the criticality. This is the most critical item, less critical item, and the least critical item. And then the third thing that is normally talked about in selective inventory control is the notion of a usage frequency. So in the usage frequency, you talk about fast moving items, slow moving items, and non-moving items. So this is known as FSN analysis, fast, slow, and non-moving analysis. So based on the product characteristics, suitable policies can be chosen for these kinds of items. So you can imagine that each one is on each analysis. It could be A, B, C, VED, and FSN. So basically this could result in 27 categories of items, right? You could talk about an AFV item and so on. So depending upon the category of each item, you could choose a suitable policy. And this is how one can actually come to this analysis.
So can you give an example of a non-moving item?
Yes, a non-moving item is one which does not move from the stores. You have many items stocked in your stores, and you find that a particular bearing you have got, there is no demand for that item in the entire factory, and you have stocked it for the last 5 years and nobody has asked for that bearing. So it's a non-moving item. So there could be slow moving items if the usage frequency is less, and it could be a fast moving item. You have every day there are requisitions for that item, so it's a fast moving item. Normally when you are dealing with non-moving items, the problem is not of inventory control, the problem is of designing the optimal stock disposal policies for such items, because you should not be stocking them. That's the idea. So items which have become obsolete, for instance, could become non-moving. A typical ABC analysis, so if you plot the values, as we said, the value of the item, which is the product of the cost of the item multiplied with the demand of the item, in that sense, so you would find invariably that of the items, less than 10% of the items maybe are responsible for something like 70 to 75% of the cost. These items are called A class items. Subsequently, the next 15% up to 25% here items are responsible for 75 to about 90% of the cost. Thereafter, if you see beyond these items have accounted for roughly 90% of the cost, and the remaining 75% of the items are responsible for only 10% of the remaining cost, in that sense, right? So this is one way of classifying items. Another way of classifying items into A, B, C is in fact that A class items are those which are 6 times average annual usage. C class items are those which are less than 0.5 times average annual usage, and B class items are in between. So this is another way of looking at the average annual usage of different types of items. Let's look at the objective of ABC analysis, and let's try to rationalize ordering policies based on this kind of analysis. What you find is, suppose we have 3 items which are to be stocked in a factory, and let's say the annual consumption value of these items are of this nature. So this is arranged in descending order, and let us say we give equal treatment to all of them. Equal treatment meaning we place 4 orders per year for each one of them. If we do that, then the value of each order will be 15,000 here, 1,000 here, and 2,250 here, and the average inventory therefore is going to be of this nature, right? It will be half of this, because the average inventory will be fluctuating from 0 to this maximum value. So these are the average inventory figures, and the total inventory will work out to something like 8125. On the other hand, if you give a preferential treatment on the basis of ABC analysis, right, we are talking about the basic utility of the ABC analysis. There is an A class item, there is a B class item, there is a C class item, let us say. And suppose we place for A class items 8 orders per year, for B class item we place 3 orders per year, and for C class we place 1 order per year only. That means we stock it in bulk. These are like small items, nuts and bolts. Buy them in one lot, bori bhar ke rakh lo, sara saal chalega. That's the kind of thing that we are trying to say. Okay. So what will happen is that these are also 12 orders, these are also 12 orders, but these are a preferential treatment on the basis of ABC. What you find is that the value of this with 8 orders now works out to only 7,500. For 3 it is 1,333. For 1 it is 1,000 here, and the average inventory is half of these, so that the total inventory falls to 4917. This is a very significant result. What it shows is that by simple procedure of giving a more preferential treatment to A class items, ordering them more frequently, increasing the number of orders, and giving a less preferential treatment to C class items, ordering them less frequently, you are able to cut down on the total inventory that you are holding. In fact, this is the basis of the typical EOQ formula with which you are already familiar. For instance, you know that in the EOQ formula for a certain item, we place the order, the stock level goes up, then you consume this at a certain rate and so on, so that the pattern of variation of inventory is the sawtooth curve. So then we can find out the carrying cost, we can find out the ordering cost, and we can do an expression for the total cost. And at this particular point, which is called the EOQ, whose formula is Q star is equal to 2 into demand into ordering cost divided by I into C under the root. This particular value therefore gives you the point where the total inventory cost is minimum. That is another aspect of how you can rationalize your ordering policies. Another important thing is the determination of the reorder point. What is the reorder point? When you have a certain stock, when your stock level falls to a certain level, you place an order. You must have noted that in the normal household, in the kitchen, when your stock is running out, for instance, when your mothers find that the stock of wheat flour is coming down, they don't wait for the wheat flour stock to go down to 0 generally. They may, but normally they don't, and therefore they place the order a little before the bin is emptied. It's called a 2-bin policy for placing orders, right? 2-bin means it's basically trying to say that you are having 2 bins, you keep consuming from the first bin. When the first bin is exhausted and you come to the second bin, that's the time you place an order. Okay, so this is a 2-bin policy in that sense. So question here that we are talking about is how to determine the reorder point. That is the point at which you will place the order. Reorder point is the maximum reasonable demand during lead time, which is the expected demand during lead time plus the safety stock. So if you assume, for instance, that the demand is normally distributed, and this is the average lead time value that you typically have, then k times this particular standard deviation will give you this particular value, and the area which is shown shaded here is in fact the probability of stock out, right, in that sense. So normally what you can do is, for different values of k, the risk of shortage that you have could be 50% if this the risk of shortage could be 50%, and the service level is then taken as 15%. If the risk of shortage is now 15.87%, which is this area, then the service level is the remaining area, which is 84.13%. If the risk of shortage is 2.28%, then the service level will be 97.72%. If the risk of shortage is smaller, then the service level is much higher. Now, what we are therefore trying to say is that this should be the region in which you will be keeping higher safety stocks. So if you want to have a smaller and smaller risk of shortage, which means a higher level of service level, then you will have to keep higher safety stocks. So normally what is the policy for A, B and C class items? For A class items, they have relatively low service levels, 0.8 or so. Now why do they have low service levels? Because A class items are important, but A class items are being handled very closely, and you are monitoring their performance very frequently. So what it means is that they will have relatively low service levels, because you would be attending to them very, very often to reduce the cost. They would have lower safety stocks consequently for A class items. Why would they have lower safety stocks? For an A class item, you would generally tend to keep a lower safety stock. Why? Because you will be coming back to that item very soon. You don't want to keep a large stock of this. If you start keeping large stock of A class items, your inventory related costs will become very high, because the cost of these items is very high. You want to cut down on their inventories. That's the reason. And you want to have a tighter control and efficient expediting. B class items would be handled routinely with service levels of 0.95 or so in this scale here. And C class items should be present in ample supply, minimum record controls. Procedure should be that we should have very high service levels. Very high service level means the probability of stock out of a C class item should not be low. It should be, probability of stock out should be very high. Sorry, the probability of risk of shortage should be very low. The probability of keeping the service level high should be there. The reason being that you will probably place orders for these items very infrequently. So you don't want that during this period the demand should arise for these items and you should not have the item. So, and since these items are less costly anyway, you can always afford to have high service levels for these items. So normally A service levels are around 0.8 or so, for B they are 9.95 or so, and for C class items service levels generally vary to 0.95 to 0.98. So I think this is an important aspect of how control is exercised when you are designing a policy for handling these various kinds of items. What are the policy implications of selective inventory control? ABC analysis, what does it mean? It means simply that A class items need continuous rigorous control. So use of mathematical models is justified for these items. B class items is generally relaxed control. So you need typically a periodic review for these controls, for these items. For C class items, even simple rules of thumb will do. That is how you handle these various items. As far as VED analysis is concerned, V class items call for a high level of service because they are vital. Therefore, you should have them in stock when they are needed. So the probability of a stock out should be small. That means you need high level of service for these items. And E class items call for medium level of service, and D class items call for a tolerable level of service. And therefore, what we are basically trying to say is that the service levels are determined jointly by whether an item is ABC or VED. So whether it's VED or AEC, depending on that you will choose a service level. And as far as FSN analysis is concerned, fast moving items, most inventory models apply to this category. Most of the research which has been done in inventory models like economic order quantity determination and so on belongs to this category. Then we have slow items which are slow spare parts, non-moving items or dead stock, which is optimal stock disposal rules are necessary for these kinds of items. Here is a typical illustration of what would happen if you are talking of a high cost of stock out and a low cost of stock out. If you are talking about a high cost of stock out and you have ABC item and a VED item, then typically what will happen is it is at this point of the matrix that this particular service level would be the highest, say 0.95. Rather it will be the highest here. This is decreasing in this direction. 0.99 here, 0.97 and 0.95 here, and then in this direction they are decreasing. As far as A class items you require about 0.8. So this is how the typical high cost of stock out would behave. If you have an item with a low cost of stock out, what will happen is that these values might be modified to something like this value comes down to 0.7 and this value comes down to about 0.85 and this is now 0.95 and 0.9. And these values would also come down to figures like 0.6 and 0.5. So this gives you some idea of how service levels can be kept for different categories of items. That means it's dependent upon ABC as well as VED analysis. What is the objective of an inventory management system? Because to manage inventories in an organization, we require an inventory management system. So basically an inventory system consists of a set of rules and procedures that allow, number one, for routine decisions on when and how much to order of each item needed in the manufacturing or procurement process. Two, which call attention to the non-routine situations the rules do not cover. So that's another thing that you want. If it's a non-routine situation, it should call attention to that. And number three, which provide managers with the necessary information to make these decisions effectively. This is an objective, and the objective of well-designed procedure should be the minimization of the costs incurred in the inventory system, attaining at the same time the customer service levels specified by the company policies. So that is how the basic objective of the inventory management system is in terms of looking at this. Let's now try to look at a typical structure of a computerized inventory management system. What does it do? It has, any inventory management system typically has these four modules or components. One is called a transactions and file maintenance module. Two is called a decision rules module. The third is called a system integrative module. And the fourth is called a system management interaction and evaluation module. Now let's see what these modules typically consist of. You see, transactions and file maintenance module is basically bookkeeping of inventory control. If some item is issued and some other items are received, so you must know exactly what are the transactions that have taken place and what is the status of inventories. So that can be done in a computerized system very easily, right? This is like maintenance of your bank account typically. So entry, auditing, control and processing of inventory transactions, and what is required is that continuous updating to provide accurate information on available stock, customer order status, cost of items, delivery time, delivery lead times, sources of acquisition and ordering restrictions. And mainly this would be required in the area, processing would be required in the area of data processing. So you have any situation where transactions are involved. So basically this is that component of inventory where you are updating the transactions. Then the second major component is the decision rules module, which will provide what kind of information, what kind of decisions have to be taken on various kinds of items. For instance, what may happen is that if you have an item, depending upon whether it's an A class item or a B class item or a C class item, which information is available in the your inventory system, then if it's an A class item, you can use EOQ and continuous monitoring and use a formula like this. If it's a B class item, you might have a policy of ordering in lots of 3 months. If the demand, 3 months demand, if stock at hand is less than the ROP. And then similarly for C class items, this order in lots of 6 months demand if the stock on hand is less than the reorder point. That means depending upon the nature of the item and a track is available, you have a set of rules which is defined in the policy which will take care of this. So optimization or rules of thumb, whatever you have. Then we have a system integrative module. The system integrative module will talk about the decision rules and the distinct inventory policies, the interaction between the two. So the various items being controlled, depending on their inherent characteristics, require specific degree of management attention and service levels that can be achieved by using some appropriate stock policy. So what particular inventory policy to use for a particular situation, what should be the service levels, these would require some kind of integration or interaction with the management to find out. So here is the module which does that. And finally, the management system management interaction and evaluation module. What do we mean by this? This is actually intended to provide management with such information as to permit evaluation of operating performance, identify problem areas, allow for management selection of policy variables or system parameters. So it's basically an evaluation module which can keep on evaluating your policies. If you keep on applying them for over a year, then at the end of it you probably find out what the costs are, and then maybe you come up with a better policy which will be able to reduce it. So next time you can incorporate this in this whole analysis. That is therefore something that can always be done. Finally, let's basically see, let's put forward some of the major conclusions and a brief summary of what we have tried to talk about today. I think the first issue that came out was that inventories are a necessary evil. You need them for some reasons. Despite what the Japanese might say of eliminating inventories and just-in-time system and no inventories, in a situation where there are uncertainties, typically of the way that we have in our country, you need inventories to overcome some of those problems. So they are omnipresent, and therefore you have to deal with them in that sense. And we also saw the various functions that inventories were performing in terms of pipeline stocks and cycle stocks and seasonal inventories and safety stocks and other speculative reasons. Then we examined the nature of inventory related costs. We talked about how the costs of procurement, the cost of holding inventories, and the cost of shortages are to be computed, and what are the components which go into this. Then we talked about this very important principle of selective inventory management, which applies to classification on different fronts. Classification on the basis of value, which is the ABC analysis, classification on the basis of criticality, which is the VED analysis, and classification on the basis of whether items are fast moving or slow moving, and that is actually FSN analysis. Because depending upon this analysis, you have different ways of dealing with those kinds of inventories. Then we talked about various ordering rules and reorder point determination. For instance, we saw that by giving a preferential treatment to certain items rather than a democratic treatment to all items is always preferable. because you tend to lower your costs. Policy implications of selective inventory management were discussed. Some of the features of computerized inventory management systems were the rudiments in terms of the basic 4 modules which are there in any typical computerized inventory management system were discussed. And then of course we are talking about the relevance, and we did not specifically talk about independent and dependent demand systems, because if we are dealing with dependent demand systems, what we are dealing with is the domain of MRP, and when we are dealing with independent demand systems of the kind that we were talking about today, we deal with basically conventional inventory control. So we'll talk about MRP, and we'll also talk about mathematical modeling in inventory systems next time, and we'll also compare MRP versus conventional inventory management in terms of the nature of the demand pattern, and we have this. So I think with this we conclude today's lecture. Thank you very much.